Hello everyone, today I will deliver the lecture. The first of all, I will try to uh, deliver lecture on bearing capacity comparison among Terzaghi, Meyerhof, Hansen, Vesic for shell foundation. Uh, and then I will discuss of bearing capacity of layer swell. The comparison of Terzaghi, Meyerhof and Hansen Vesic, you can see here is the final outcome. We can see the lowest bearing capacity is taken Terzaghi, and then Hansen, and then Basic, and then Meyerhof. So you can question which method we will use. I will say the Terzaghi will use, as it is taken the lowest bearing capacity. And second, the topic is bearing capacity of layer swell. What is the layer swell? We can see here the two type of layer. One is stronger swell and another is weak swell. So we'll cover this topics. So let's start first of all the bearing capacity comparison among that. So let's start here. We can see sorry, okay, so here is an example. We can see here for a rectangular footing as shown. Following figure determine the gross ultimate bearing capacity Q using first of all is Terzaghi bearing capacity, and then the general bearing capacity equation of Meyerhof, and then general bearing capacity equation of Hansen, and then general bearing capacity of Vasic. So this is the soil profile. We can see here is a EGL, which means existing ground level, and the DF is 3 feet and C is 20 kilonewton and phi 35, and groundwater level is 1.5 below of the EGL, and gamma is 16, and gamma saturated 80 kilonewton per meter cube, and foundation size 2 meter by 3 meter. So let's start. As a solution, at first I will try to solve this question in Terzaghi's bearing capacity. So as we know, this is the rectangular footing, that's why we will use ultimate bearing capacity 1.3 C and C Q and Q 0.4 gamma beta. So for phi 35 we will find out C by 50.75 and 41.44, and gamma is 41.08. So how we'll get this? We'll go to the Terzaghi's bearing capacity chart. So when the phi is 35, then we'll see phi and C and Q and gamma. So put this value here, and putting all the values here, and found Q is 36.285 kilonewton per meter square. Ultimate will be 3274 kilonewton meter. So let's see the another solution, which is solved by Meyerhof equation. So this is the equation we have shown here, and when the phi is 35, then NC and Q and gamma will be changed. So let's see what is the NC and gamma and Q. So for Meyerhof, phi equal to 35. This is taken from I can see the BM dash what I will say, equation from the BM dash. Okay, so if you go to the BM dash table 16.3, then you can find phi equal to 35, and for NC equal to 46.12, and NQ equal to 33.30 and 37.15. So this is the chart for bearing capacity, and putting all this bearing capacity here, and Q equal to putting all this value, and shape factor C is found 1.549, and the general bearing, this is the shape factor of FQS, and FCD depth and depth shape factor, and inclination factor is 1, and putting all the values here, and found the ultimate bearing capacity 46.10 kilonewton per meter square. So number 3, we will solve this with Hansen. The all the equation is same, but change will be when the phi is 35. The change will NC and Q and N gamma. Especially change will be N gamma. So let's see what is the here is the Hansen. This is the Hansen. So when phi then NC equal to 46.12 and NQ equal to 33.3, but N gamma will be 33.92 and 33.92. So putting all these value here, and shape factor FQS and F gamma S, and depth factor and inclination factor is putting here, and all the and ultimate bearing capacity. We putting all these value and find the ultimate bearing capacity 43.23 kilonewton per meter square. And last one we will find out the basis equation for general for getting the bearing capacity of soil. So this is the same the remains same equation, but the change will be N gamma. When the phi equal to 35, then N is equal to 46.12 and N gamma 30.33. Let's see how we'll get. This is the equation 46.12 and 30.33. For basic, N gamma is changed 48.03. So we have used 48.03, and putting all this value with factor, then we'll find the ultimate bearing capacity for 4407 kilonewton per meter square. And this is the summary. We have found the comparison bearing capacity we have found by Terzaghi, which is 32.74, and the Meyerhof we have found 46.10, Hansen we have found 4323, and the Vesic 4407. So we have you can question me which one will use in practical life. So I will suggest as an engineer. So I will suggest we can use the Terzaghi equation for the getting the lowest bearing capacity, as we will take the take the safe zone. Okay, so this is the first topic we have done. So second topic, bearing capacity of layer soil of the foundation. This is the layer soil. You can see the two layers. So let's start the layer soil. Okay. Before going to the solving the problem, then I want to say some theory on bearing layer soil. So bearing capacity of layer soil: stronger soil under weaker soil. So Meyerhof and Hanna developed a theory elastic ultimate bearing capacity of shallow foundation. Continuous foundation supports the strong layer underlying the weaker layer soil, as figure is given 12.2. You can see here is a stronger soil and another is weaker soil. Okay, so according to their theory, the ultimate load is area Q is the failure surface area, so and will be as shown. It's also shared, and the ratio H by P is relatively small, and punching shear failure occurred in the top stronger soil, followed by the general shear failure in the bottom. So this is the punching shear. Okay, so let's see the considering ultimate length of the continuous foundation of the bearing capacity given this equation, and we can see B is a bad unit at C equal to cohesive, and also many things is given here. And another equation we have been seen for ultimate bearing capacity, and then we can take the more the equation. So note that Q1 and Q2 will ultimately bearing capacity will found from the equations. So this is the another graph. You can see the stronger soil and there is a weaker soil, and this is the failure zone at the bottom of the footing. So stronger soil and ultimate bearing soil here is the case. And this is the another method, but we will not use this method today. Okay, so let's see the example. Here is the example. Okay, let's start. So calculate the ultimate or gross bearing capacity of 2 meter strip footing of soil given below. So this is the strip footing. So don't think it is a square or rectangular footing. So You can see here the saturated is 16 is given here, and gamma 15.6, and depth of footing df is 1.8, and gamma unsaturated is 16.9, and c equal to 0 and 28. So and age is 32, age equal to 3.2. Always age will be always depth always from the bottom of the footing. Okay, so remember it. Okay, as this is the steep footing, that's why we will use the shape vector fcs gamma css qs is 1. As there is no load on inclination load, that's why fci fqi and fqi will be 1. So at first I have been taking, there is a two type of gamma. Here's gamma is 28, here's 28, and another gamma is 37. Okay, so let's see. When gamma is 28, then we will go to the Meyerhof equation here. We can see here 28, that will be 25, n c equal to 25, and n q 14, and n gamma equal to 11.19. So we can see gamma is 11.19 for 37, and q for 37, here is a 37, and gamma will be 53.27. so L 53.27. so we can see the another chart is here. This is the chart. This is the design chart for NQ and N gamma application to weaken over soil. We can see here the bearing capacity factor NQ1. So this is the one, and the right side, and the bottom side is NQ, and this is the H divided by B. H, what is this? What does mean H? H is I have already discussed, said H is nothing but H is the depth from bottom of the footing to the layer, desired layer. This is the called H. So this is given is 3.2. So if we get the H divided by 2, H divided by B, and found 1.6. 1.6 is this is here. So in this way we will go to the here, and dotted line is intersect with this, and this is value will be used here. So this is the schematic diagram we have seen. Here is a nq gamma 1 and nq gamma 2. Then we can know here is divided by b is 1.6. This is the is divided 1 by 6, and intersect this point, and found n gamma 1 is 11.19. So 11.19 is found from graph 1. So another graph 1 we can see here. We can see another graph 1 here. N gamma 1 is right side, and n gamma 2 is left side, and H by B is 1.6. So this is 5 and 1.6. This is intersect this point, or this dotted line. So this dotted line is intersect here, actually intersect here, and found it is almost 21. So n gamma q1 prime is 21. So this two value we have found from this graph. So we have to remember that. So now is q equal to gamma prime into df. Df is given here 1.8 depth of footing, and found 11.14. So this is the chart I have been taking here, and gamma equal to when phi equal to 28. Why we will take the phi? When the phi is more and more phi, then we will take only phi, which is the which is the bottom of the immediate bottom of the phi. So this we can see this is the 1 phi, and this is the 2 phi, but we will take this layer phi. Why? Because the footing is rest of this layer. So that's why we will take the phi of 28 degree. Okay, so we will take only 20 degree, and I found that depth factor is 1.3. So putting this value ultimate q ultimate, and found 394.7 Newton. Okay, so before we going We can see the Q net equal to Q ultimate divided by Q, which is 383.56, and allowable will be Q net divided by factor of safety. We have taken the factor of safety is 2 3 and found 27.86. So we can see another example for the individual shallow foundation given in below. To calculate the ultimate cross bearing capacity if two homogeneous soil layer are found at ground level up to 12 meter. The upper layer soil is having 5 to 25 is ground from ground level to 3.5, and the underlying soil layer has 5 to is 45. So this is the given in question. You can see here is a footing which is 3 into 4, and the age is given from 3.5 1.7, and phi is 25, and layer 1 and layer 2 phi is 45, and C is 0 is for all the footing, all the soil. So inclination factor is 1, as there is no particle forces or inclined forces. Sorry, there is no inclined force. Okay, so phi is given 25. This is the 25, and this is the rest of the first layer of the phi. That's how you will find out all the shape factor, depth factor, and inclination factor. So when phi is 25, then we will find NQ, and N gamma is 6.6. So NQ, we have found this chart. H by B is 0.57. So H is nothing but H is here the 1.5, 1.7, and B is given is 3. So 3 divided 1.7 divided by 3 is 0.57, and found this is the intersect is here, and found N gamma in 6.66. So this is the intersecting this point here, and found 6.66. Okay. So second graph we have shown here. NQ2 is right side, and NQ bottom side, and right side is NQ1, and the remaining is by B ratio 0.57. This is the 0.57, and intersect this point, and found NQ prime is 40. Okay, so this is for we have found this and this graph. Okay, so these two value we are taking from the graph. I am saying again and again, and the two value NQ gamma prime and NQ gamma prime is 40. Okay, so now we using the Meyerhof equation, and found the ultimate bearing capacity is 678.9 kilonewton per cubic meter, and net will be 667.76, and the allowable bearing capacity will be 2 to 2.59 kilonewton per meter cube. So you can see another example. To calculate the ultimate or cross bearing capacity of footing is medium dense and overlying dense sand, and phi equal to 25 and phi equal to 45, and water table at the ground level, and diameter of rectangular 3 into 4 is given and 2, and the upper layer extension 6.5 meter below the level. So this is the our soil profile. You can see at TF equal to 2 and H equal to 4.5, and the depth is the footing dimension is 3 and 4 meter, and medium sense layer phi is given 25, and C equal to 25, saturated 18, and dense soil layer phi 2 is 45, C 0, and saturated 22. So when phi is 25, so we can use the inclination factor, shape factor, and depth factor. So these factor will be find out 20 when the phi is 25. Okay, we can see here the two type of phi is 25 and phi is 45. When we can use the shape factor and depth inclination factor, then we use 25 also, or 25 only. Why? Because the footing is rest immediately this layer. That's why we will use 25. Okay, I hope that you can understand. When phi equal to 25, then NC1 and gamma we can use from Meyerhof equation of chart. Here is a Meyerhof chart. Here you can find from BM Dashi the foundation of bearing foundation of the geotechnical books, and found this table from 16.3, and the equation is here. And when phi equal to here, then we can found this from BM dash book, and phi equal to 45, then found this BM dash here. Now we can use this this value, and you use this in this graph when nq1 is right side, and n gamma 2 is left side. So let's see, we can see the n gamma is 6.6 is 6.6 in is, and we can see h by b ratio is 1.5. What is h? H is the depth from immediate of footing to the first layer is 4.5, and b is 3. B is given is 3, and found 1.5. So 1.5 is intersect this line, and found gamma prime is 4.55, 6.67. And the same way we can use this n gamma 2. N gamma 2 is n gamma nq2, and found nq2, and found nq prime is 10.6 is, and putting in all this value, and found 1193.29, and the net will be 117.9, and the allowable will be net divided by factor of safety, and 392.3. And we can see another example is calculate the gross ultimate bearing capacity, which is 2.5 wide strip. This is the strip footing, and soil buffer is given here. This is the soil buffer, you can see here, and phi equal to 25, and another phi equal to 32. So when phi equal to 24, then we can use this shape factor, inclination factor, and shape factor, and found all this with respect to when phi equal to 25. So we can found this. Now when phi equal to 25, then we can found nq1 and nq2 from the Meyerhof chart. Okay, so when nq2 is 32, then we can found here 32. This is taken from there, and h by b is 1.2. How is h equal to nothing but from bottom of the footing to the first layer, which is 3. Okay, which is 3 divided by 2.5 by 1.2, and we'll use this graph, and found n gamma 1 5.2, and from this graph n q prime is 40. So n gamma 1 is 5.72, and n q prime is 14. This is found from the layer soil graph. So ultimate will be 200.85 kN per meter square. So this lecture is in depth. If you have any question, then let me know. I think you can find anything. If you find anything fault from me, then you can comments or let me know. So I want to ensure that this is the graph of this is the design chart for nq and n gamma applicable to weak soil layer. So this graph is taken from reliable sources. You can use them, and this is the chart from the Meyerhof getting the nq, n gamma, and nq equations, and this is also the bearing capacity chart from NC for n gamma for Meyerhof, n gamma for Vesic and Hansen, and this is the chart is only for Terzaghi. You can use this graph only for Terzaghi. Okay, so if you have any question, let me know. I want to try to solve your questions. Thank you everyone. Thank you.